Hey everyone, welcome to the 5.2 notes. Today we are going to learn how to add, subtract, and multiply radicals. So when you are adding and subtracting, combining radicals is similar to combining like terms. They have to be common radicals. In order to get a common radical, you have to have the same index. So they both have to either be square roots, or they both have to be cube roots, or they both have to be fourth roots. You can't combine a square root and a cube root, and they have to have the same radicand. Just a reminder that this is just a fancy way of saying that the inside part has to be the same. They do not need to have the same coefficient or number in front. Everything else pretty much has to be the same. And what we're going to do is simplify first so that we can actually tell whether or not they have the same index and radicand. Then we're going to identify common radicals and add or subtract the coefficients. But we won't be changing the radical at this point. So for example, on this first one, we need to split up 27 into two numbers that multiply to 27, one of which needs to be a perfect square, like 4 or 9 or 16. 4 doesn't go into 27, so I'm going to skip to 9. 9 times 3 is 27. These are both in the square root still. Then the square root of 9 is 3, which gets to come outside since we've already done the square root. But the other 3 has to stay inside because there is no square root of 3. Then I'm going to bring down the 3 that was already in front, this one, and it gets multiplied to whatever came outside from the simplifying right here. So that really is 9 square roots of 3. Then I'm going to do the same thing over here. 12 is 4 times 3. The square root of 4 is 2. The 3 stays underneath because there is no square root of 3. And there was a negative 2 in front. That's going to come right here. Negative 2 times 2 is negative 4. Okay, so whatever number comes out of the square root gets multiplied by the number that was already there, which is why this is negative 4. Now we have 9 square roots of 3 minus 4 square roots of 3. And sometimes thinking it or saying it out loud like that helps. Because when this looks kind of confusing until we think of it as 9 square roots of 3 and 4 square roots of 3. 9 minus 4 is 5, but you don't change the square root. It stays the same. Okay, because they had the same root, it was a square root, and they were both 3. Okay, now we're going to do a problem with cube roots. So when I split up the numbers for the cube root, I want to find two numbers that multiply to 54, but I want one of them to be a perfect cube. So perfect cubes are like 8, 27. So 54 divided by 8 is a decimal, but 54 divided by 27 is 2. So 54 is 27 times 2. So if you're not sure what goes into 54, take your calculator and just start dividing it by perfect cubes. That's why we made a list of them on 5.1 notes. Then the cube root of 27 is 3, because 3 to the third power is 27. Don't forget the little 3 there. Okay, and then I had a 3 out front already, so that's going to come right here in front and make this 9 cube roots of 2. And then you'll notice this one is already the cube root of 2. So it actually doesn't have to change at all. It's just going to come straight down. And I do have to simplify this last one. I'm going to look for two things that multiply to 16, one of which is a perfect cube. 8 is a perfect cube. So I'm going to change this to negative 8 times 2. When you have a negative, pull that in front when you do the cube root of 8. So the cube root of 8 is 2. The cube root of negative 8 is just simply negative 2. And then there is no cube root of 2, so it stays underneath. Okay, so this cube root of negative 8 is negative 2. And then we're going to pull down the 7 that was already out front and multiply it. And 7 times negative 2 is negative 14, cube root 2. Now, you will notice that all 3 of these have a cube root of 2. So they really have to have the whole radical the same. The only thing that can be different is the number out front. So now we're going to do 9 minus 2 minus 14. 9 minus 2 is 7. 7 minus 14 is negative 7. Cube roots of 2. And voila. Okay, sometimes not all of them get to combine. Sometimes there will be some parts that don't. So I'm going to go through this one a little bit quicker. I need a perfect square that goes into 28. That's going to be 4 and 7. Because 4, the square root of 4 is 2. And I'm going to go ahead and cross this out and write my 2 outside like this. And I had that 10 in front. So that makes this 20 square roots of 7. And then I have a cube root over here, so I need 2 numbers that go into 56, but I need one of them to be a perfect cube. So I'm going to try 8, 8, and 7. And then the cube root of 8 is 2. And there was no number out front of this one, so I'm just going to leave the plus right there. And I'm going to come over here to the negative 4 times the square root of 175. I'm going to try perfect squares with 175 because it's in a square root. So I'm just going down my list of perfect squares and trying all of them until I get one that doesn't have a decimal, which is 25 and 7. And the square root of 25 is 5. And then you've got this negative 4. Sorry, I didn't leave quite enough room. And negative 4 times 5 is negative 20. And you will notice that I now have 7 inside of all of my radicals, except for this one is the odd one out. 2 cube roots of 7. None of the other ones have a cube root. So I'm just going to copy it down over here, and I'm going to cross it out because I already dealt with it. These two both have the square root of 7. 20 square roots of 7 minus 20 square roots of 7 is 0. So that's just my answer right there. Okay, on this next one, I'm going to actually just kind of show you it this way. 98 is 49 times 2. That means that the square root of 49 is 7, gets to come out front. So I have 7 square roots of 2, and then I have to deal with my exponents. So remember that a square root is always an imaginary 2 right here. And to simplify the exponents, you're going to ask yourself, how many times does this go into the exponents? The number of times goes out front, and the leftover stays inside the radical. 2 goes into 4 twice, so an x squared gets to go outside. 2 goes into 2 once, so a y to the first power gets to come outside, leaving me with the square root of 2, because there were no remainders when I did my dividing. And then over here, nothing can change with the square root of 2. So it's not going to change at all. Bloop, stays the same. And then I'm just going to subtract these, because they both have the square root of 2. So the question you have to ask yourself is, can you subtract these parts? Well, they have the same variables, so yeah, these are like terms. And 7 minus 3 would be 4 x squared y's. And then you have the square root of 2 left afterwards, too. So that one gets a little funky. All right, let's talk about multiplying. Multiplying is probably going to be the easier part because you just basically have to follow these 2 rules. Anything that's outside can get multiplied together, and anything inside can get multiplied together. And by the way, this should not say parentheses, this should say radical. I mean, it works with parentheses too, but it should say radical. And then basically this is how it works. 27 times 5 is 135. And then you're going to try and simplify the square root of 135 if you can. And there we go, 9 and 15. I'm going to cross that out, right? It's 9 times 15. And then the square root of 9 is 3. And the 15 has to stay underneath. And there you go. So just make sure you always simplify it at the end if you can. And then I know this one looks a little different, a little weird. This is a multiplication symbol right here. So it's not subtracting, it's multiplying. So what you're going to start with is multiply the 3 and the negative 2, because those are both outside, and then multiply the 10 and the 18, because those are both inside. Okay, so really we're just doing that and that. And then I need to try and simplify the square root of 180. 4 goes into 180, but this still has a lot of other numbers that go into it. 9 goes into 180, but this still has a lot of numbers that go into it. So I'm going to keep searching. And I'm just going in order. I know you could probably eliminate some of these yourself. 36 and 5. And the square root of 36 is 6. 5 has to stay underneath. And then you already had that negative 6 in front right here. So that's going to make this negative 36 square roots of 5. Because we got to multiply negative 6 times 6. Boom. Okay, and I'm going to keep doing a couple extras just to give you guys more to see. 2 times 5. Keep the cube root and multiply 9 and negative 24, which is negative 216. And 216 is actually on our perfect cubes list. It is 6 cubed. So the cube root of negative 216 is negative 6. And 10 times negative 6 is negative 60. And then we have this down here. You can put a 1 in front if you want. Negative 3 times negative 1. Multiply the outsides together first. And you have the fourth root. And you're going to do 64 times 8, which is 512. Make sure you keep the fourth root. And this is on our list of perfect fourth powers. But if you're not sure, let's say you don't know what the fourth root of 512 is, you can always do this. Go to the math button. Go down to where there's a little X outside. And what it wants you to do is type a number here. So if you forget to type a number first, it's going to take whatever your answer was. You need to go change that to a fourth root of 512. 4.76. Which means it's not a perfect one, so we have to find a perfect one that goes into it. Let's see. Our perfect cubes list had 216 on it. No. 343. So I'm trying the big ones first because I'm not even going to try it all. That's a... And I think I might have found it. 512 divided by 256. There we go. So 256 and 2. And again, I'm going down our list of perfect fourth powers that we had in our notes. That's how I ended up with 256. And then the fourth root of 256 is 4. So I'm going to multiply that by the 3 that was already out there, which makes me 12 fourth roots of 2. Okay, on this next one, we can put a 1 out front. Multiply the numbers outside. 1 times 5 is 5. And multiply the numbers inside. 6 times 8, 48. X to the fourth and x to the fifth. This is like saying you have 4 x's being multiplied and 5. When we put that together, it makes 9. Okay, square root of 48, that will be 16 times 3, which makes this 4 square roots of 3, with that 5 out front, okay, or 20, and then the square root of 3. I'm leaving a little gap because I also have to deal with my x to the 9th. We're going to see how many times 2 goes into 9. That's 4. So x to the 4th comes outside. And there's a leftover of 1, so x to the 1st has to stay inside. Or 20x to the 4th square root of 3x. And there you have it. And last but not least, over here, the numbers out front are 2 and 7, which makes 14. 4th roots of 2p's and 3p's makes 5p's. 1q and 10q's makes 11q's. And 4 goes into 5 once, so we can put a p to the 1st power outside. And it has a remainder of 1, so you need to leave a p to the 1st power inside. 4 goes into 11 twice, so you're going to put q squared out here. That's only 8, so we have a remainder of 3 to get to 11. So q to the power of 3 is going to be left inside. And there you have it.